OK, so what we're going to do is the first 10, 15 minutes, hopefully 10, more than 15, we're going to talk about how we use AI in decision making, going beyond insights. And then I would like to make it very interactive. And what I would like to ask all of you is to think about the most impactful decision making that happens at your companies. And we're going to try to scope that out into an AI project right here, right now. So we'll see how it goes. I've done this a couple of times before, and some very interesting decision algorithms come out, some for which I don't want to be associated. But anyway, let's, if this clicker cooperates, which it's not. Hello?
Can we get some help?
Clicker. There you go. So what do businesses really want from AI? We've seen a lot of presentations, and there's a lot of thoughts around that and opining. Typically, what businesses want is questions like what I have up here. And when you actually look at these questions, let me highlight for you what's interesting across the board with these questions is that they're all about new insights. I want to get this new chart, this new model that gives me some new information that's quite critical, which is all interesting. It's all well and good. But when you ask them, what will you do if you get these insights? The answers typically look like this. Some action that I will take or a human is going to take. So for some reason, and I know what the reason is, it's because of the nature of the breakthroughs in AI today are all about advanced and robust model building. We think that the insights part is something we're going to delegate to AI, and it's going to come up with these new patterns in our existing data or whatever. But the actual actioning on those insights is the exclusive purview of humans. But I want to make a case that we humans aren't that good at decision making, and we do need some help from the AI. This clicker is, there you go. So insights alone are not enough. All you're going to get is more and more of this. And so what we want to do is go beyond insights. Why? Here's one reason. The choice is not always obvious. If somebody told you that you are, with a high probability, going to miss your revenue targets by the end of the quarter or the end of the year, what are you going to do about it? There are many, many different choices. And which combination, where to apply them, it's not obvious. If somebody tells you that your costs are high, again, it's not obvious what you want to do. You know, should I lay off some people? Who? Should I renegotiate supplier prices? Invest in efficiency? How much of what? Where? What does my strategy tell me? It's not obvious. Then there's the case of the outcomes that we're solving for. I would like to make a claim that in most cases, if not all, in business, our decision making is not solving for just one objective. And we are not very good at solving or decision making against more than one outcome. And because of that, we set up our companies in a way where the divisions have different objectives. So we have, the finance team is all about saving money and cutting costs. And the sales team is all about maximizing sales and revenue. And they're always kind of in a clash. But the company as a whole has all of those objectives in mind. Why? Because if all we wanted to do was to cut costs, we can cut costs. We can just fire everyone and go home. That's cost zero. Or if all we want to do is maximize sales, we can just sell everything for free. That's not what we want to do. It's a combination of more than one objective, and humans aren't very good at that. The other case I would like to make with respect to decision making is the fact that if all we do is go out and build this gnarly big model to give us new insights based on our data, the world is going to change. And so our decision making has to keep up with a changing world. And so it's not enough just to go collect tons and tons of data and build a model on top of that. So what are we going to do about it? We are going to automate and augment our decision making. In order to do that, let's first look at a simple model of how we as humans make decisions. We are in a context. That context is whatever information we have about now or historical information that we have that we typically look at in order to make a decision. So that's a context. And then we take an action out of possible actions. We don't just take the action randomly. We select what action to take. And we do that in a manner by which to optimize outcomes. So that's a simple model for how we make decisions. And if I show you this chart, this is basically, let me give you an analogy for this. How do we make decisions? Let me just go back. Sorry, we have a decision strategy, in other words. So we pick these actions based on some form of strategy. It's not just haphazard or random. That strategy, where did that come from? It's from experience. It's from a mental model of the world. So as new contexts present themselves, we strategize against what we believe the world is going to, we believe the world is going to react to our actions. And that mental model tells us how to act, right? So what if we can actually build this? What we're going to do is we're going to take all the historical decision data that we have that most of the time you guys have captured in your organizations. We will look at the context in which a decision was made and what action was taken or set of actions in that context. And we will also look at the outcomes. And these outcomes might be lagging. They might be outcomes that happened, tomorrow, or in 2 weeks, or in 2 months, or in a year. That's still fine. As long as we can associate an outcome or multiple outcomes to a decision, we're fine. So now we have a database of historical decisions that we've made. Then we use off-the-shelf data science and create what we call a predictor. What the predictor does, given any context, even context we haven't seen before, it comes up, and an action that we suggest, it comes up with the outcome. It tells us, if you do this in this context, this is what the outcome is going to be, with different degrees of confidence. We can build this. This is simple model building. We can build this. Once we do, then we use evolutionary AI, and we can talk about how that works a little later, but we use evolutionary AI to actually come up with a decision strategy. Let me just say that evolutionary AI in this case is very similar to us trying out different strategies in our head against that mental model, because the predictor is actually relatively cheap to interrogate, because it's a model of the world. It's not the actual world. It would be much more costly and risky if we just kept trying stuff out against the real world. And so we come up with the best possible decision strategy given the data and the knowledge that we already have. Then we use that to augment our decisions. So the end system is going to look like this. The human that's been making the decision all the way up until now is now going to have a suggested decision or action coming from the AI with some form of confidence range that says, I think this is what you need to do, and I'm this confident in this suggestion. And the human can take it or tweak it, or just discard it and do their own whatever they want to do. And then we collect that data. So this, what we call this outer loop, keeps continuing, because it's not a one-time affair. As the world changes, we kind of keep up with that. And we collect whatever happened. Even if the human deviated from what we suggested, we collect what happened. And we keep improving our mental model or that predictor, and by virtue of that, improving our decision strategy. So talked about the predictor. This is the prescriptor. The reason why we use evolutionary AI is because evolutionary AI allows us to test out many, many strategies at the same time and take bits and pieces of the strategies that are doing better and put them together in new candidate strategies that we try out. And because of that, it allows us to be very efficient in searching a large search space, and it allows multi-objective search. So as I said, most decision problems are multi-objective problems. OK, so just to give you a visual of how this looks like, if the x-axis is the context and the y-axis is the action that we want to take, and each dot is a decision, and the absolute truth about everything in the world is the halo that you see in the background that obviously we don't know about because we don't know anything, we don't know everything about the world. And let's assume that a line going through action equals 0 is the best possible action you can take. So what I'm going to do is I'm going to run this system, and it'll start trying out various different actions. Initially, it knows nothing about the world. But as it tries different actions, it not only learns what the best decision strategy is, it's also learning more about the world as well. So that halo in the background is starting to form. That neural network that we have that is our predictor is starting to learn more and more about the world. But notice that it's not just doing this in a very risky manner and trying everything out. That's costly and difficult. And the state of the art in AI, by the way, is that. It's let's try out the universe of possibilities before we build a model. This is not that. This is saying incrementally improve on your decision making, which is the way humans do that. Notice that after a while, we're aligning with action equals 0. And the background is starting to look like the ground truth. So that's just for you to have a visual of how this looks like. If I plot the decisions that we made, because we didn't know anything about the world initially, the first few decisions were costly, not very good. But very quickly, most of our decisions are pretty optimal. So a few quick examples before we do our whiteboarding. We've used this in some very interesting tasks, for example, to learn how to grow plants in controlled environments. There isn't a lot of data there. In fact, the past 10, 12,000 years of humans growing plants, there hasn't been data pertaining to just take away the context, the latitude, longitude, or soil type, and just tell us how to grow plants. So what we did is we worked with MIT, where they actually have these contained environments to grow plants. And it's just a power cable going in, and everything else is completely controlled. And they didn't know how to grow plants. Plants, in this case basil, is fast growing. That's 6 to 8 weeks from seedling to full plant. So this is a lagging outcome, right? But in spite of that, we were able to optimize for more than one objective. One objective was the size of the plant, the fresh weight of the fully grown plant. The other was the taste. And we were able to actually optimize against the two using the same model. So we have some data which is kind of conservative. It's very much bunched around where the agriculture scientists kind of think that we should be. We have that data. We take that, we build a model, and then we interrogate the model and come up with the best growth strategy, and then go out and grow. And then as we get the data back, we go through that loop over and over again. We did that. And with very little data, in fact, and not too many iterations, it found some very interesting things. One is that it found that the larger the plants, the less tasty, which is like, duh, of course we kind of know that, right? Tiny little tomato is juicier. But it also found out that in spite of the fact that the agriculture scientists thought that basil needed 6 to 8 hours of sleep, like darkness, every 24 hours, it turns out that it doesn't. And in fact, if you shine light on basil 24/7 for part of its growth, it thrives. We didn't know that. Nobody knew that. But incrementally, the system pushed the boundaries and found it. And so the system can be really creative and find decision criteria for you and decision strategies that you've not thought of in the past. We use this within Cognizant. In fact, actually just today, I think we announced that we won a big award for this one, which is RFP comes in. They want us to test some software, and we have to decide how to respond to the RFP. That's action. This is a case of us eating our own dog food. We're kind of using this internally. We want to reduce cost while maximizing speed and quality. So that's the data set. I won't go into detail for that. Another one is underwriting. Just to give you a visual of how a system like this works, underwriter comes in. They have to underwrite or insure properties. They scroll down, pick one of these properties. There's, on the left-hand side, a whole bunch of information and data, and they can go out and do research more on that particular property. But on the right-hand side is what the AI is telling them. A, it's saying, yes, insure this one property. B, it's saying, insure it at an 80K to 90K premium. It's giving us an 85% confidence. And it's also predicting what the risk is going to be, a risk that's measured a few months out. So I'm going to stop right here. There's more to this we can cover later. I think we have about 10 minutes. What I want to do is a few brave volunteers to describe to me, and the more esoteric the better, but the way you need to think about it is this is a decision cycle that's critical to your business, that's currently more or less done manually, and we'll do some interactions to try to scope it out and see if we can use AI to help with it. So any takers, any volunteers? Yes?
Okay.
Khalid.
Okay. So we are a satellite company.
Satellite company.
Satellites, and we run them.
Okay.
And we transfer video through the RF, and we also provide our customers with internet.
Okay.
Right. So we have two operation centers. One for the ground operations, which is the networks, and another one for the satellites.
Mm-hmm.
The problem is, when I came on board, that we all do descriptive analysis. We collect data and we describe it and we say, oh yeah, we know everything. So we started to get more into prediction, and we are now stepping towards descriptive analysis. So the challenge is the documentation of how they solved the previous problems, so we can get that.
But I get it. So, but what is the decision that's being made today for which you need it?
Is, do we need to go towards cognitive analysis or use the expertise of that?
Yes, but that's a one-time decision. That's a strategy decision.
Yep.
For that, I don't know if I can help you.
Okay.
But is there a decision-making happening? For example, I don't know, what would be? Is it a decision-making that's happening on a constant basis?
Yeah, based on that decision, we make decisions every day in
Yeah.
the knock and solve.
What kind of decisions?
Do I need to restart the modem? Do I need to
Okay, perfect.
send the technician out? Do I need to
Perfect. So it's some form of dispatch decision, right? Or remote restart or whatever, right, on the modems. Okay, great. And what are you solving for here? For when you're trying to do this? Is obviously you can't always be restarting the modems, and you can't always be dispatching. So one of the outcomes that you're looking at is cost, right? So you want to make sure you minimize the cost of maintaining.
Yeah, and basically the cost here is time.
The cost here is not just time, because it would be very fast for you to remote restart a modem, right?
Yeah, but how much time does it take you until you decide that you need to?
Perfect. So I would actually set that as a second objective. I think there's cost and there is time, and you want to minimize both. But then there's a quality aspect or something on the other side. You can't constantly be restarting or sending dispatchers out there to.
Yeah, of course, because every time you start it, there is milliseconds of outage that happens to the customer.
Okay, perfect. So there's something called uptime, maybe, yeah?
Yep.
Of the actual device itself that you want to maximize. Okay, so let's leave it as the three objectives here. You mentioned that there are a few actions that you take. So let's talk about the actions. So the actions are send a dispatcher was one, yeah?
The least critical one.
Yes, it is. Why? Because it's the costliest, right? Yeah.
Fly somebody out.
Fly somebody out, and right? Then there is, I think you said remote restart. Is that an option?
Yeah, restart, and also that's the decision to make if we don't have all the remote sites which we built 20 years ago. We don't
Right.
have remote virtualization on them.
Exactly. So actually, that you're starting to go into the context information here, because that is a contextual information that's very important. Whether we have what was it you call it?
Right equipment to virtualize and remotely restart the modem or the bottom.
Okay. So equipment type and configuration is one. Is there there's a geography aspect to where this right? So there's a geo. For where the equipment lies. What else is there?
And It's the detection of, because around the world we have gateways that transfer our signal to the satellite and then broadcast it to the remote sites, which our clients.
Right.
And our clients are thousands
Right.
around the world.
Okay.
So
So
geo is very important.
so that's interesting. So the target audience for the particular device becomes important, right? Like how big is it? How valuable it is. Is that a decision criteria? So like if this is like North America where you make the most money, you really want to dispatch someone as soon as possible and get this restarted. But if it's maybe that's not a good example.
It's not only that, but
Yeah.
also like Real Caribbean, which did the presentation today. They are our customers, so they are moving targets and they are in the middle of the sea.
Yeah.
And we have cargo ships. And
So that
we
would
have
be
airlines.
geo, yeah. But I would say the population affected would be another factor,
Yeah.
right? So,
Situation of the customer, like you provide a satellite for the video streaming that you see on airplanes.
let's call it customer state. Yeah, very important. Okay, so this is one example. We did this one very quickly. But what I'm saying here is that currently, I'm assuming that this choice of whether to send dispatcher or remote restart, and I'm sure there are other choices to be made, right now this is human-made, right? So what I'm advocating is that you have a historical you have the history of this. What do you have? You have the context when it was like 2 years ago or 6 months ago, whatever, and you know what you did. You've captured that, and I bet you do have information around
That's
this,
the whole
right?
actions that we took. It hasn't been documented all the time.
Okay, so that's an interesting question. In some cases, what we see is that the actual information is not captured. There are extreme cases where the actual actions aren't captured either. So we had, I think it was a medical or healthcare related one, where we're talking to them and they're like, we don't even know what the practitioner is actually doing. We haven't captured the action itself. Doesn't really matter. You have to start somewhere. And if you actually build, for example, an interface like this is the interface that will be capturing that anyway, right? So you have to start somewhere is what I say. We can, I don't know how much time we have. Can we do one more or no? Yeah? 2 minutes. Let's do one more. Any takers? Come on, decision making. I mean, I had the case where people were saying we don't know how to do our like quarterly budget assignment. That's a big one. Or the guy I was talking to an insurance company. They're like, yeah, let's do telematics for trucks and whatever. When I actually started talking to him, he's like, underwriting is by far and away the most critical decision making that we do. So I'm sure there's more. Is there anyone?
How about hiring the right talent?
Hiring the right talent, love it. Okay, all right, hiring the right talent. So what are the outcomes you're solving for? You want to hire as quickly as possible, obviously. So there's a speed element that you're maximizing. There's a quality element if you can measure it. Or maybe that's kind of reflected in an attrition element, right? So if somebody sticks around for a while after you hire them, that probably means they were quality enough to keep. So maybe we put that in there. So I don't know how to, attrition maybe. But remember, this is going to be on a per individual basis, right? We're not aggregating. We're saying this particular individual that we hired stuck around for 3 years. That's what we're looking for.
And emotional intelligence quality as well as technical?
Yes. How do you measure it?
By account.
Do you measure it already right now?
Well, yeah, their performance on accounts.
Right. Performance. So we can put that as let's put it as performance, but it could be that it's kind of built into attrition in some ways as well. These two might be the same thing. I think there's a cost element here too, by the way, because if it really costs you a lot to bring in someone, then that kind of defeats the purpose, right? And that might be partly the package you give them, the money you pay headhunters to bring them on board. There's a lot of elements that come into the cost side, right? So those are the outcomes. The action, there's a simple action here. But it's OK. It's a critical action, which is hire, yes, no, right? So we want to know whether we want to hire or not. That would be one action. Are there any other actions that you take on a candidate that comes in that might be?
Like periodic reviews.
But that's so I would suggest that's a different decision cycle that's related to this one, but it's not the same, right? Yes.
So how do you account for bias in this exercise?
That's a great question, and Purnima, actually sitting in the back there, had a session on that. That's a whole new discussion. One thing I would suggest is people think about their ethics policy and codify it. I think that's one of the first things every one of us need to do, because that's when you codify something, you can actually implement it. But that's just one idea, but there's more. But let's not digress. I think there's another question here, which is the package. Right? So that includes dollars, or somehow does translate into dollars ultimately. But actually, thinking about it, the bias question here is important too. And I think I would put it down as in the outcome side. Right? If you measure, for example, the gender or the race or diversity of your workforce, and you want to keep it balanced, so that might be something that you actually have as an outcome that you're optimizing for. Just putting it out there. OK, so and then the context. Obviously, for the context, we have the requirements. Nobody can read my handwriting anyway. Requirements for the job. We have the qualifications. Should I put gender here? No. Right? That's exactly another area where you have to be very sensitive.
The domain expertise goes.
Domain expertise, I would put it under qualifications, but yes, absolutely. But one way to address, partially, it doesn't fully address it, but one way to address questions of bias is to make sure that the data that you feed into your system isn't conducive to bias. But this system will solve for that if you actually set it as the outcome optimization as well. But these are just two. There's I don't know if you have the prior salary. You might have comparables, right? You might have sourcing info. Where did they come from, right? Was this like they filled out a form online, or is this coming through a headhunter or whatever? So there's more data. So I think you catch the drift. A system like this, all of us have hired, right? We've made hiring decisions over and over and over again. Much of this data is already reflected in our systems. They're not in one place. They're in different tables. We are doing quality assessments. We know how long an individual stayed around, how many times they hopped between jobs or departments. All that is there. This info is, obviously we have, and there's a lot of this that we have already too. So there's no reason why we can't AI enable this system. This one, right now, I would say should absolutely be a decision augmentation system, not the least because if it goes wrong, we want to blame the human. That was a joke. Sorry. So I think we're done. Thank you very much and for playing along. Thank you.